We're going to cover 3 technologies with this video today. Number 1, the AMD chipset, which is the X670 Extreme. Number 2, 20 gigabit USB-C. And number 3, we're going to take a look at something else that was announced that brings us into focus about the chipset, because that's the number 1 requirement for PCI Express 5. We're going to take a look about the specs and what's required, because some have asked, they'd like to see that tested. So we need to go through all that about the Gigabyte Aorus Generation 5 add-in card, which is a by 16 card that requires 4x4x4x4, 16 lanes, fully bifurcated. So of the 4 requirements, number 1 being PCI Express 5, number 2, you've got to have a 16-lane slot. Number 3, it has to be able to be bifurcated in the motherboard BIOS, full bifurcation of 4x4x4x4. And then of the 3, number 4 is going to be, you're going to have 4 M.2 NVMe drives. And the first generation of those right now is going to be about 10,000 megabytes. Now the spec for PCI Express 5 can take that up to 15,000 megabytes. But I expect we're going to see probably 3 generations like we did with PCI Express 4. So we're going to be looking at the Phison E26 Controller when the time comes, and with Micron Memory. Now this time around, we don't have any PDF files to look at. And I said when we did the X570 chipset for AMD, I almost felt like that was a little bit premature, but this is even more premature, because then at least we had specs from AMD. So what we've been able to do is, of the 5 motherboard manufacturers, take a look at the different ones, of 2 we're going to show you, and pull some information into what we've been able to read and ascertain. Because as always, when you guys ask, it's about slots and storage. And what y'all want is what we have here in front of us. And this happens to be the Gigabyte TRX40 Designaire, where we have 2 16-lane slots and 2 8-lane slots. Those are dedicated resources. First of all, let's lay the platform. When we're talking about consumer desktop motherboards, which is what this chipset is, and this is PCI Express 5, the only way you're going to get PCI Express 5 is on a consumer desktop motherboard. Above that is a high-end desktop, which is what's in front of me. And that looks like it's been abandoned, for better or worse, kind of indifferent. I'm really bummed about it. I know a lot of you are. That we're not going to see any more high-end desktops. Okay, so then you've got to leap over that for a workstation. And then above the workstation, the server, and above that, enterprise. To reiterate, everything right now with PCI Express 5 is on the consumer desktop motherboard. So as we look at the requirements to get that Gigabyte card working on a motherboard, we're going to outline some of these resources as it relates to slots and storage, because that's the questions you guys are always asking. Then we're going to look at USB-C, because there's 10 gigabit, 20 gigabit, and then there's 40 gigabit, and I want to get into that. So let's take a look at one of the motherboards with the information we've pulled out, and I'm going to, I'll just share the document I've got instead of showing you the link. All those links will be in the description. We've actually got 2 links from AMD. I've got a link from Gigabyte we're going to show you information. One from Asus. The information from BioStar was pretty generic, and trying to look at the information and extrapolate from MSI is really difficult. And I wish they would clean some of that up. But to reiterate, we do not have technical specs. So we're pulling what we've got, trying to figure it out. And the 2 things we're always looking at for slots and storage are PCI Express lanes. So we have to look at motherboard, CPU, and chipset. And to look at those 3 items, what we're looking at are CPU lanes and chipset lanes. Because when we bifurcate a slot, which is what we're doing when we put an add-in card on a motherboard, and we've looked at a lot of them, and a lot of you guys who had a lot of interest in it, those are CPU lanes. Chipset lanes, different animal. Now, as always we say, change one thing, changes everything. For example, if you say, and we're going to get into the slot and lane assignment for slots and storage in just a minute. If you were to say, I need, say, a slot for the GPU, and that's an issue we've got here, because I'm going to come back to that. What do we get with the AMD X670E chipset? Number 1, we get a faster CPU. Number 2, we get faster RAM. And number 3, what do we get? We get a faster bus. So of those 3 things, there are 2 things that are kind of important that don't change. What are those 2 things? 1, our CPU core count does not change. Now, everything we do is related to content creation for rendering. So we follow, even though there are different rendering engines, and the only thing that really is a variable is the GPU you use for rendering based on the render engine. But to reiterate, the rendering engine that we follow, and I don't use Adobe software, is the Adobe After Effects Multi-Frame Rendering CPU Optimization Formula with two requirements that state: number one, CPU cores times 4 equals RAM. So if you have a 16-core CPU times 4, that's 64 gigs of RAM. These motherboards are going to support, from what we were able to figure out, it's going to be dual channel, and there's also some information that says a DDR5 memory stick is dual channel within one slot. That may be correct, but the way it's referred to by AMD and the motherboards is dual channel. There'll be 4 slots, 128 gigs. And we don't know yet how the memory controller is set up. We know how it was on the 5000 series CPUs. We don't know how it's going to be set up on the 7000 series CPUs. The memory controller problem they had where you took a performance hit hopefully won't be an issue. But to reiterate, the two things: number one, CPU core count does not change on this platform, which is the consumer desktop motherboard. If you want more CPU cores, high-end desktop or workstation. But if you want PCI Express 5, consumer desktop motherboard. Now, how many lanes we have and how many and how those are divvied out, that's a bit of an issue. And I've read information with supporting documentation that says two different ways are correct, but I'm going to go with what AMD says based on what little bit they've said, and I'm going to follow that. But I'm going to share with you, and I'll give you two numbers. Anyway, to reiterate, it's not enough lanes to put that add-in card on a machine, which means if you're going to have 4 drives at 10,000 megabytes per second times 4, what we've seen for speed is you will acquire the speed of 3 minus 1. So if you're in RAID 0, which is what I call RAID by the seat of your pants, because RAID 0 is all about capacity and speed, then if you have if you have 4 10,000 megabyte drives, then you're going to have 3 times 10, which is 30,000 megabytes. I've seen some of the numbers that have been talked about, but I'm referencing this based on what we've done. Yes, I love to test it, but to test it, the requirements that have to be met. So we're still going to get into slots and storage, and we've still got some more about USB, because there's a couple of things that came in light as I've been answering subscriber questions that you guys have asked that I didn't know about Thunderbolt 4 and USB 4 until the question that was asked was specific to a chipset. And what I realized was the first chipsets that had Thunderbolt 4 and USB 4 are different than the second set of chipsets that had the same thing. And that one item is about PCI Express tunneling over USB 4. There's a setting in the BIOS, because to get USB 4 working is going to take two things: one, BIOS support, and two, driver support, which is the chipset. But if you don't have that setting in the BIOS to turn that on, you won't get that feature, which was about PCI Express tunneling. We were asked about that on 2 different chipsets for Intel. I'll bring up the information and share with you as it relates to that. But that is a question we have with these going forward that I don't know yet. But it's a question I want to know. There's another question about USB-C as we go through 10 gigabit, 20 gigabit, and 40 gigabit. Now, 40 gigabit USB-C is Thunderbolt 3 and Thunderbolt 4, and the difference is bidirectional bandwidth. Okay, one of our subscribers recently commented that something can still be Thunderbolt compatible and only running at half the speed, which would put it, instead of at 40 gigabit, would be 20 gigabit. It is what it is. Now, we have to remember, Thunderbolt 3 and Thunderbolt 4 are based on PCI Express 3. So some of these things that we're looking at have a lot to do with what's going on with these chipsets. Because when AMD first announced these chipsets, I thought we were looking at 3 different chipsets. The one at the top of the food chain that gives you the most opportunity and advantage is the one we're talking about. However, that one chipset that we're talking about, which is the X670 Extreme, is based on the X670. And both of those are actually 2 chipsets, which is the 3rd chipset being announced, because that one chipset, which is the... Before I get into that, let's take a look at what AMD has given us. 2 links that deal with, I believe it was Computex from 2022, so this is fairly current. And all this stuff with these new CPUs, these new chipsets, This stuff's coming out pretty soon, but this is kind of an overview of implementation that we want to share with you as these three come together. And to reiterate, these links will be in the description. Okay, the Ryzen 7000 processor. Advantage is going to be graphics built into it, which I question how many cores, because that's not ideally how you want to have your rendering set up. And you'll have DDR5 and PCI Express 5 supported on that chipset, aside from the other things they talk about. Okay, here we are, the three chipsets, the X670E that we're talking about, the X670, and then the B650. The first two chipsets are based on that last chipset. That last chipset, to reiterate, the B650 chipset, which is one chipset, is actually going to be two chipsets to make up those others. And the difference in the 670E and the 670 is, again, to reiterate, going to be the availability of resources. If you want the maximum amount of resources that I'm going to go through and itemize, then you want the X670 Extreme. However, it's almost like what we used to have with a North Bridge and a South Bridge, those two chipsets. So I don't know if they're going to call it that or if they're going to call it the primary and the secondary. But what you'll have is a secondary chipset connected to the primary chipset through PCI Express lanes that'll be chipset lanes. Then you have the CPU that connects with a primary chipset, and those are going to be CPU lanes. But those CPU lanes that are PCI Express 5 are going to be downgraded to PCI Express 4 to connect to that chipset. So if you look at AMD versus Intel, Intel is going to have what they call 8 DMI lanes, which connect the chipset to the CPU. Whereas anything that goes through these double chipsets, you've got one chipset that connects to another chipset, and that chipset then connects to the CPU. And all that from down here to here up to here is going to be 4 lanes. So to reiterate, MSI is the only one I've seen previously through the chipset that could allocate a slot to 8 lanes. That's going to be important because those are chipset lanes. Everybody else is using 4-lane slots. The reason that's relevant is because as we get into the resources, remember I mentioned about what doesn't change. The CPU core count does not change, 16 cores. If you want more cores, you got to go to a different platform. When you go to a different platform, right now, you don't get PCI Express 5 when you change. High-end desktop, X299, X399, TRX40. When you get into the workstation, then you're either looking at something from Intel, or if you want the latest, which is from AMD, which is what we recommend. And I guess that's because of our perception and perspective on what we know that makes the WRX80 the platform to go to, but it's PCI Express 4, but it's 8-channel as opposed to double-channel memory. Yes, it's PCI Express 4, DDR4. Yes, this is PCI Express 5, DDR5. And again, back to that add-in card, you've got to have, right now, unless something else is going on, the consumer desktop motherboard. Now, keep in mind some perspective. As we talk about this, with all three of these things that we want to impress upon you, keep in mind about a year ago, Gigabyte announced an 8-drive card, 4 and 4, which means that's a self-bifurcated card, and we think it's based on the High Point card. We haven't seen hide nor hair of it yet, but we did a video about it. So this time I didn't want to do a video about this version 5 card by itself. I wanted to pull it into what was required to run that card, which is PCI Express 5, which is this chipset. So all this kind of stuff. Now, if someone says, I want 20 gigabit, because someone's going to ask about upgrading. Okay, on the high-end desktop, everything was 10 gigabit. That was as fast as you could go. Or you could have Thunderbolt 3 like we have in this computer. And this add-in card is the Gigabyte Titan Ridge Thunderbolt 3 add-in card, and it's in an 8-lane slot. So there's 4 lanes there that we don't get to use. We kind of lose. To reiterate, 2 16-lane slots, 2 8-lane slots, and we're using 4 lanes for that. And we've done a lot of videos about that because of issues with what I call bus prioritization, about the out of PCI Express resources. There's an issue with the BIOS, there's an issue with the firmware on the Thunderbolt card, and because of that prioritization, the GPU and Thunderbolt had to be next to each other. And I've just helped somebody else, or tried to, that's having that same out of PCI Express resource error, D4. We didn't get it resolved, but I helped them to understand what the problem is because they still need a BIOS update. Anyway, I don't mean to digress, but all this stuff is related. So as we look at these 3 chipsets, knowing that the 2 high-end chipsets are actually combination chipsets, it's supposed to be a less expensive and simpler design where this could affect the price, which brings up an interesting question, price and performance. I can see a $350 motherboard on this. A $500 motherboard is a bit of a pinch, kind of a stretch, because right now those are not listed on PC Part Picker. They will be eventually because they're the consumer desktop. PC Part Picker doesn't list anything above that. When we go above, we got to do some of our manual work, which I don't mind. It gets fascinating. But as we look at what's available right now, which is nothing, we have preliminary information and anything could change until we have some solid information. Like, I'm always looking for congruent information. I want to see those motherboard manuals because there's information in those manuals specifically about the BIOS, and there's sometimes configuration asterisks and stars, the gotchas and what ifs, that because you're talking shared resources. For example, say you've got a motherboard, and we're going to get into the resources about how this is allocated. Because they are shared, you might have a motherboard that says there are 2 slots that we're going to look at that are by 16. What that means is those are by 16 mechanically, but electrically, because of slot and lane allocations, you've only got so many that are shared, and you might have 5 M.2 drives supported on that motherboard, but it's give and take. If you take something, you got to give something. To reiterate, if you have 2 slots on a motherboard, or if you have 3 slots on a motherboard, chances are, if it's 4 lanes or more, those 2 slots, if they're to the CPU, will be 2 8-lane slots electrically. One by itself will be by 16. So for a quad card like we've talked about, that ain't going to work. If you're going to put a quad card on one of these machines, that's PCI Express 5, which is what you want, with this chipset, it's going to have to go in that primary slot. The secondary slot, you have to forget it exists. So then your GPU either has to come out of the CPU, or it's got to go in a slot that's coming from the chipset, which is probably going to be 4 lanes. It might be 8 lanes, but that depends. Until we get more information, we don't know. The only one that would do that through the chipset would be MSI. Some more details. Now, for the AMD socket AM5 total platform input-output, there's going to be 24 PCI Express 5.0 lanes. And that says storage and graphics, so that implies, for what we're reading, those are CPU lanes. Chipset lanes could be the same, could be, and I've seen 2 numbers floated, 24 and 28, and I've seen them flipped. And I've seen documentation that says it can be both ways, and I'll put up some links from some very respected sources. So my understanding and reading of this, there's some other information AMD has that will help us to ascertain that. But right now, it looks like we have 24 lanes. To the CPU, up to 14 USB with 20 gigabit Type-C. Okay, according to the spec, from what we've been able to read, which is not published yet, but you've got a lot of stuff you've got to pull, there could be anywhere from 1 or 3 20 gigabit USB-C ports. And the question is going to be, is that native chipset support, or is that a separate chipset? Because of the 3 things that USB-C can do that we're going to get into in just a minute, remember there's 10 gigabit and 20 gigabit, and when you go to 40 gigabit, which is not, because remember, Thunderbolt 3 and Thunderbolt 4 are based on PCI Express 3, and that's only good for about 31 gigabit. We're not talking bandwidth. We're talking about burst mode versus throughput. And when we're talking about specs, that's about burst mode. Throughput's going to be down, a lot lower than that. The number is, as always, from what we've been doing, is test and verify, because your results may vary, and a lot of variables, things can be different, but it's going to be less. More specs. We're just trying to hit the high points. There's also going to be up to 4 DisplayPort ports, HDMI 2.1 and DisplayPort. Now that says 2 ports, but up to 4. Now to bring up about USB-C. USB-C can do 3 things. Data, all of it. Power delivery, some of them. And number 3 is DP Alt mode, or DisplayPort Alternate mode. If the chipset supports it, it'll be there. Now what you're looking for when you see a 20 gigabit USB-C port, it's probably going to be labeled as USB-C 2x2. So whenever you see 2x2, so how does that relate to the systems we've talked about in motherboards? The first time I saw it, I didn't really pay any attention to it, but then I remembered it and I started going back and looking, and when some of this other stuff came up you guys were asking questions about, it was like, oh, that's what that is. So I like to refer to it as 10 gigabit and 20 gigabit, and 20 gigabit USB-C is a USB-C port that's 2x2, because it's going to take 4 PCI Express lanes. How those lanes are allocated could be CPU, probably is going to be through chipset, but I've seen a lot of different stuff that even says there's going to be some USB 2 ports allocated through the CPU, which is kind of weird because it doesn't make sense as you lay out the lanes. If you got one 16-lane slot and you got the second resource, which will be 4 lanes, that's 20 lanes. And if you have 24 lanes, those other 4 lanes are going to connect the CPU to the chipset. Now, if there's 4 more lanes, where are they being used? Could be something like that, could be discretionary, which would depend upon the manufacturer. We don't have enough information to make that determination. So the numbers of 24 and 28 are the 2 numbers we're seeing being bounced around for that reason, because there's lots of resources. But as much as there is, there's not enough for an add-in card to have a GPU on a 16-lane slot and to have that new Generation 5 adapter from Gigabyte on a 16-lane slot. You have to prioritize. If you want the storage, you got to have the slot, and you've only got 1 slot. If you want the GPU separate because you're doing rendering, then that's your priority because you got 1 16-lane slot, unless you don't mind it being in something else through the chipset. Because remember, 4 M.2 NVMe drives, which is bifurcation for 4 lanes for each drive, hence 16 lanes, 4x4 is 16. So you have to consider all these things. And when you guys ask questions, I find it absolutely fascinating to take a look at a motherboard, but I had to know the motherboard, the CPU, and the chipset, and then we go through and sort that out because we look at the design, and this is about design versus implementation, and every motherboard has a different implementation. It's just crazy. Now, of the 5 different manufacturers of motherboards, I've mentioned them. 2 we're going to look at. 1 we're going to look at will be some information and specs that I'll share the link with, but I want to use my notes to show you because it's easier with what I've got, I think, to focus on what I want you to see. One's going to be Gigabyte, which gives some information. I got to tell you, I've always thought Asus had the best information, but right now, it's Gigabyte. And the other motherboard we're going to look at is going to be Asus. And to reiterate, there are the 5 brands of motherboards: ASRock, Asus, BioStar, Gigabyte, and MSI. And the 2, to reiterate, we're going to look at will be Gigabyte and the one from Asus. Oh, and I got to interject. I saw in some of the notes from Asus that they're going to have a ProArt version of this in the X670E at some point. Now, resources don't change. It's still a consumer desktop motherboard, but I'm excited to see what they're going to do for that because that would be something for content creation. And another question kind of comes up that really needs to be interjected here. If someone says, what platform should I build on? Well, you want the new stuff, but remember, this is only going to be DDR5. And this is only going to be PCI Express 5, but in some iterations, it's going to support PCI Express 4, and in some iterations, it's going to support PCI Express 3. But everything I'm telling you, take this with a grain of salt and weigh what I'm telling you and sharing with you with what's going to happen as we learn more, because once we learn more, then we'll come back and do something again, hopefully, if we're able, on some of these other motherboards, as you guys ask questions. Okay, the ecosystem. Before we look at the 2 motherboards, everything's going to be faster, and to reiterate, we've got 3 things that are faster. So there's a lot of information in play here to keep in mind. Consumer desktop motherboard, PCI Express 5, we've got an adapter we want to use, what's required to make that work. And we're talking about content creation, so content creation is all about the rendering. Could be CPU rendering, but more specifically, it's about GPU rendering because the GPU can do 80% of the rendering depending on what you're doing. So all these pieces of information are a state of play, but those specs talk about CPU cores, amount of RAM, CPU cores, and video RAM. Nothing about the speed of it. Keep that in mind. So everything with this is about faster. Okay, another link we want to share with you, and if you look at the top at the URL, it's pretty obvious. This is the AM5 socket platform set to change, and it's focused on gaming. So if anybody starts talking workstation or content creation or high-end desktop, this ain't it. This is about gaming. We don't do gaming, but we're trying to share with you about the specs. PCI Express 5, to reiterate, 24 lanes to the CPU, 14 USB connections, 20 gigabit USB-C. Wi-Fi, hard yet to comment about Wi-Fi because Wi-Fi is typically 1 lane. Typically, Wi-Fi with 1 lane is something that's predefined and allocated, but I have seen motherboards in previous chipsets where it's an either or. In other words, you could use a 1-lane slot because of shared resources, or you could use Wi-Fi, but you couldn't use both. Now, we're going to see SATA ports on these boards anywhere from 6 to 8, depending on resource allocation. And typically what we've seen in the past is you'll have 4 that are hardwired. You'll have either 2 or 4 that can be a shared resource. So if you've got a motherboard that has a 16-lane slot and says it can support 5 drives, and that's one of the curious things about the Asus board because there's a couple of add-in cards that they're including with some of the motherboards. One of them looks like a DIMM adapter. I'll give you the name of it. And the other looks like it's a dedicated PCI Express 5 adapter. In previous iterations of PCI Express 5, it was a dual adapter for PCI Express 4, but it was a single adapter for PCI Express 5. No separate information that we can share unless we get our hands on one of the motherboards that had that. But there's some interesting stuff going on. Let's keep looking. Now this brings up a good point about the cooling solutions. The only thing I've seen, and I think I saw it today, was about Noctua. Instead of taking and putting 5 dollops on the CPU and compressing that for the best thermal conductivity, they're putting 1 dop of that paste right on the center because the CPU design is different in the way it's laid out underneath that cover, which was kind of interesting. But to reiterate, you'll be able to use the same kind of cooling interface on the AM5 that you used on the AM4. It's just the arrangement of the thermal paste is a little bit different, which is to me a little bit weird because on a TRX40 or a WRX80, it's a completely different pattern. You want to cover that whole thing. But to reiterate, change one thing changes everything. So again, the 5 motherboards, and they've got a survey there if you want to complete it a little further down. Now this talks about expanded instruction set for AI accelerated and neural networks and machine learning. So, I always ask, what's the intent and purpose? And again, to reiterate, we focus on content creation for rendering. And we had one subscriber that just built a machine on a chipset that I thought he needed a workstation to do some of this kind of stuff. So I hope it works out and does what he wants. But even though this is a gaming computer, they're talking about doing some of this other stuff with it. But remember, you're talking 16 CPU cores. So depending on the formula for whatever you're working with, I look at the software you're using and see what the requirements are and work accordingly. Now we're going to take a look at one of those 2 motherboards. This is the Gigabyte X670E Aorus Master Revision 1, key features. And I've pulled out the information I want to focus on because I'm going to share that with you. Nanocarbon coated M.2 heatsinks, which is kind of nice. Another thing I find most fascinating is it also lists the thermal conductivity, which is a first, on the thermal pad, which is 12 W/MK. And yes, that's decent. Remember, the default Thermal Grizzly 8 is 8 W/MK. And we've seen thermal pads, I think, as high as 17 W/MK. So to get a stock pad at 12 W/MK, that's pretty amazing. And I appreciate the fact that Gigabyte told us that. I want to point that out. DDR5 dual channel ECC support. And because of ECC support, that lends credence to what we had with a high-end desktop and with the WRX80 on the workstation and above, because if you're doing the kind of work it talked about in the document that I've just referenced, you'd want something like ECC support. Okay, this brings up an interesting issue with RAM. Whatever motherboard you buy, check the QVL, buy accordingly. I expect we're going to have some issues with BIOS updates. And the BIOS, remember, can do 3 things. One, it can update the motherboard BIOS because you're talking about compatibility with everything from CPU to slots to storage. So everybody likes each other, and RAM, so that's all copacetic. The second thing you're talking about is being able to update the AGESA code in the CPU for the same reasons. And the third thing that might be updated, if there's firmware, which I'm going to get into in this motherboard, which is kind of interesting because it opens up another door for some more technology. Firmware update on Thunderbolt 4 or possibly USB4. I'll show you, we'll get there. So keep that in mind. Now this motherboard says 2 PCI Express 5.0 slots and 2 PCI Express 4.0 M.2 drives. Okay, to reiterate, that has to be 2 slots that if used simultaneously will be by 8 per slot because there's not enough PCI Express lanes to the CPU to accommodate 2 16-lane slots. It ain't there. No BIOS update's going to fix that. A Realtek audio codec. Now here's a nice one. 1 PCI Express 5 by 16 slot to reiterate. And 2 slots means there's going to be 2 by 8 electrically, not just mechanically. There's going to be 1 PCI Express 4.0 by 4 slot. That's got to be through the chipset. That's important to know. And then there's going to be 1 PCI Express 3.0 by 2 slot, 2.5 gigabit LAN, Intel Wi-Fi, 20 gigabit USB-C with DisplayPort Alternate mode. Now, one of the things you're going to want to look for is, number one, are you going to have 20 gigabit USB-C for your connectivity for devices? But number two, for connectivity for external devices, because we talk a lot about portable storage, internal and external, high-performance portable storage. What about other features? Because remember, there's three features of USB-C: data, power, and DisplayPort Alternate mode. If that support is there, they're going to tell you. If it's not there, it probably won't be. And that's going to be important and essential because if you have, say you're using the onboard video, which will support 2 to 4 connectors and you want to add more displays, then if you've got one USB-C port with alternate mode, you can plug in another monitor. If you've got three monitors. Act accordingly. So it's another way to get more connectivity. And then the other one that's really the fascinating one is the USB4. Look at this. On this motherboard, there's a USB4 add-in card. Now, what we don't know about that add-in card, is it included with the motherboard or is it going to be a separate item? A couple of years ago, I said it's going to be included. Based on what's going on right now, since the world's turned upside down, I expect it's going to be another card that's going to be an add-on. But the big question about USB4, because remember, Thunderbolt 4 should support USB 4 if it's allowed, but it depends on the chipset. And I still got a couple of Intel chipsets. I'll share that with you where things change. But the feature you're looking for is PCI Express tunneling over USB 4. And when we first started fielding that question, that's when we realized that's a big deal. DisplayPort HDMI, and this motherboard is going to have 6 SATA ports. Now the next motherboard, this is an Asus Republica Gamers Crosshair X670E Extreme. And what's noticeable here, this lists, as I mentioned earlier, 5 M.2 slots. And it lists one of the add-in cards. There's another add-in card I've seen mentioned, which is the Republica Gamers Gen-Z.2. And without knowing the facts or seeing the manual or the technical specs, I think that is that DIMM card where you put you put an M.2 drive on each side of that card in a DIMM slot. I think that's what that is. But there's another card that's been referenced that I don't see here, but I've seen it in some of the other motherboards as Asus has talked about this. And the other thing you're looking at, that USB generation 2x2 port is to the front. Okay, so 20 gigabit USB-C to the front. Sometimes a question comes up, for those that are going to plug in a headset, like an Oculus or whatever, you want to have that USB-C port to the front. And I don't know that 10 gigabit will do what you want, but you might be doing storage through that, so you want to have it through the front. We need to see the motherboards, which we don't have yet, to understand where all the connectors are. We don't have that. So all we can do is read what they've given us. There's probably going to be some ports out the back for USB-C. There'll be 10 gigabit. What's going to be 20 gigabit? Up for conjecture. All we know is what they've given us so far. And on this motherboard, there's going to be support for dual USB 4. So those 2 ports for USB 4, and hopefully that supports PCI Express tunneling. But again, we need to see it in the motherboard manual about the BIOS. That's pretty neat. So if you're looking at the technologies and you're trying to decide what to build, 3 things we've talked about. The chipset. If you want the chipset that gives you the most amount of resources, it's the X670E. As we talked about, the Gigabyte Aorus Gen5 add-in card, of the 4 requirements it has, you got to have a chipset. This chipset will do it. But there's requirements and hoops you got to jump through to make it work. And the third thing we've talked about that I wanted to impress upon you is 20 gigabit, because we have 10 gigabit, 20 gigabit, and then the 40 gigabit, which is Thunderbolt 3, Thunderbolt 4. You know where that goes. A little bit more. Now this motherboard, if you'll notice, has the Marvel 10 gigabit Ethernet, which is nice. It also has the Intel 2.5 gigabit Ethernet, which is fine. And we talked about devices that you would set up for network attached storage, such as the Blackmagic Cloud Store that has 10 gigabit Ethernet. It'd be great with something like this. But it's something that, you know, if you need it, great. If you don't, it's there. But that's 4 PCI Express lanes. And you have to think about those resources, whether they are shared or whether they're dedicated. Depends on the layout. Depends on what they decide to do. Connectivity, PCI Express 5. And again, the ROG Gen-Z.2 card. Generation 5 M.2 slots. And then the USB-C 20 gigabit, which is a 2x2 to the front. And then the USB4 ports. It mentions the Realtek audio codec, also an ESS digital audio converter. I wish we had more information, but it is what it is. And of course the link into Asus, that is the master link. And if we look up here at the top, I want you to see all that before I clear that out. This is the AMD AM5 X670 and B650 chipsets. Everything is based on the B650. The X670, which is 2 chipsets of the B650, and to reiterate, the X670E, which is the Extreme. There's also going to be, from Asus, according to their documentation, as we're talking about the X670E, and I keep saying to re-emphasize Extreme, to reiterate, Asus is now saying they're going to have another line of motherboards that are going to be X670E Extreme. So beyond just, I don't know, price, performance, all these resources to be considered of the different things you want to do. We're talking shared resources. You have to decide, do you want PCI Express 5 or do you want PCI Express 4? Do you want dual channel memory or do you want 8 channel memory? On the workstation platform, you can go from 16 cores to 24 to 32 on up. So you have to decide which platform you want to be on and what you want to do. And 20 gigabit is pretty fair and simple and straightforward. However, another little piece of information, this chipset that AMD is using, which is going to be a primary and a secondary chipset, AMD has been designing that with AS Media. So we're going to see another chipset on the motherboards. If it's not native chipset support, it'll be a separate AS Media chipset. Now, I can give you a link to a USB-C, or excuse me, to a 20 gigabit USB-C chipset from AS Media, but it's the previous version. The latest version that's going to be on here is not out yet, but there are some that'll talk about it. I'll put up that information in the description. And what that other chipset will support is going to be fascinating, such as, will it support, if it's separate under the AS Media name, DisplayPort Alternate mode? We don't know. Now, this is the Asus X670E motherboard landing page. And this is where they're going to be keeping all their information when they start announcing everything. So I'll get rid of that. Choose your X670E motherboard. We looked at the X670 Extreme. There's going to be a Crosshair Hero, a Crosshair X670E Gene, and we can look at some of the tech specs. Here's a good example. This first one's going to support 4 DIMMs. The second one will support 4 DIMMs, 128 gigs. But the third one will support 2 DIMMs, 64 gigs. As I said, design versus implementation. You have to decide what you want and how those resources are allocated. And this is good information here that wasn't up a few days ago. There's going to be 4 out of the 5 drives. 4 of them will be PCI Express 5. To reiterate, one of those is going to be to the CPU. Those others have to be through the chipset. And one's going to be PCI Express 4. Same kind of configuration. Look here. You got 3 PCI Express 5 and 2 PCI Express 4. It depends on how other resources are allocated. Because if we look down here at USB, right here we have 2 USB4 ports, and we have 2 USB 20 gigabit ports, which is the 2x2. And to reiterate, under USB, all those configurations are different. And you can see how changing those ports, because whether it's a 10 gigabit, a 20 gigabit port, or a 40 gigabit, if it's going to take 2 lanes or if it's going to take 4 lanes. When you change that lane allocation, it changes what your storage is about. And you guys always ask about slots and storage. This is what happens. And again, to reiterate, Marvel 10 gigabit Ethernet, 4 lanes. And this one has 2 USB 20 gigabit ports, or what I like to refer to as 20 gigabit USB-C, and it's got 2.5 gigabit Ethernet. And if we look at the third one that has less memory allocated to it, 2 PCI Express 5.0 M.2 drives, 1 PCI Express 4.0, and you can see how the USB is affected and how that's allocated, and the LAN on that is 2.5 gigabit Ethernet. So this motherboard would probably be the first one to be most desirable. The question is going to be the cost. $350 to $500 for the motherboard. When you start looking at a workstation, you're looking at a motherboard that has plenty of resources, nothing's shared. A couple of features are shared, but for the most part, all your slots are dedicated and all your M.2 connectors are dedicated. To reiterate, you're looking at PCI Express 4, dedicated resources, but again, PCI Express 4, nothing with PCI Express 5. But a workstation motherboard, it's about twice the price. A motherboard may be twice the price, but you got more than 4 times the resources. You're not dealing with 24 or 28 lanes. You're dealing with lanes to have enough 16-lane slots electrically to get 6 or 7 16-lane slots electrically, not just mechanically. So these are all things you have to consider on where you want to be with a consumer desktop motherboard for PCI Express 5. This is where it's at. I have to wonder, and I have to interject again, for that card to be announced from Gigabyte, what else is coming down the pike that we don't know about? But as these 3 relate, we can put 20 gigabit with an add-in card on just about any motherboard, but we're going to have a 4-lane slot for that card. PCI Express 5, consumer desktop motherboard, until something higher end comes along. And as far as the slots, there's nothing you can do about those slots. A motherboard will have 2 slots or it'll have 3 slots, and there'll be some probably 1-lane slots. Could be 1, could be 3, depends. But every 1-lane slot is 1 PCI Express lane. So you have to keep that in mind, how those are allocated. It's always give and take. Now, I mentioned the AS Media chipset. The only one that we can see right now is the ASM 3242, and that's for 20 gigabit USB-C. The other one, Tech Power Up, has an article about this other one, which is going to be an AS Media 4242 that we can't pull information up about yet, that will do more stuff, such as, I think it's going to support DisplayPort Alternate mode, whereas the first one did not. And I would also expect in time, not only will that chipset be built onto the new motherboards that we're looking at that we don't know yet, but I expect in time that chipset will be offered on add-in cards so it can be installed in another machine. Don't know that for a fact, but I'm thinking that's possible because AS Media had another chipset that worked for USB-C. It doesn't exist anymore, but the chipset supported DisplayPort Alternate mode. There was only one company that made one card. It's probably 2 years ago. It's gone. For those that are interested, I can put up a link if you're interested in the technology. But that's what I expect with this new chipset. But everything's up for conjecture until something actually becomes a reality. And with this new chipset, this says this will be a full 40 gigabit USB 4 with a Generation 3x2 support. We need more information. Now, something else I want to interject that you're going to see on these new motherboards. Some will say Thunderbolt 4 and some will say USB 4. If it says Thunderbolt 4, that implies it's an Intel chipset. Intel has had 2 chipsets for Thunderbolt 4. I'll show you both right quick. If it says USB 4, more than likely it's going to be the AS Media chipset, unless it's native chipset support within the X670 Extreme chipset. So be aware of that with what you read and interpolate what they actually are implying. Now, the chipset we associate with Intel Thunderbolt 4, that's the JHL8540. And if you look over here, that was the Maple Ridge. And if we scroll down on the Maple Ridge, that was a 2-port, which is what we see, by 4 Generation 3, so it's 4 lanes, PCI Express 3, shows the capabilities, and it talks about tunneling on DisplayPort. The other chipset that Intel has is the JHL8440 Thunderbolt 4 controller, and that one was formerly Goshen Ridge, and supposedly that was supposed to be on laptops. I'm not seeing anything that has it. And if we scroll down, that's supposed to be Thunderbolt USB 4 peripheral support at 40 gigabit, and it's supposed to support DisplayPort Alternate mode. So it has the tunneling capabilities, and it would support 2 displays. And the port configuration is 4 ports. But I've never seen anything more on that other than the specs. I've never seen anybody talk about using it. Technology is what it is, so I don't know if there's a lot I don't know. But I wanted to share it with you so you kind of have an understanding of the technology. And we're going to have a link up in the video cards, this article about 2 AMD X670 Promontory 21 chipsets that reportedly will cost less than one X570 chipset, which is kind of curious. Now, what got us on this deal about PCI Express tunneling through USB 4? Okay, now I'm going to tell you about a couple of Intel chipsets. And I got to look at my notes as I talk about this. We had a question from a subscriber about the Z590 chipset, and he said, why can't I enable that? I thought, well, it should be there. I pulled the manual down and looked, and then I compared it to a Z690. And that's when I realized the technology for that feature on that motherboard, apparently for that chipset, based on what we could see, because it was based on the Asus Republic of Gamer Strix Z590 e-gaming Wi-Fi motherboard. Why couldn't he enable USB 4 tunneling? Not supported. However, if we go down, and that motherboard had the Thunderbolt header for Thunderbolt 4, and that's something you want to look at when you're doing an add-in card. Does your motherboard support Thunderbolt 3 or does your motherboard support Thunderbolt 4? Because we've had questions about that. You have to buy the card according to what your motherboard is supported based on the documentation from the vendor. And there's plenty of information about that from Asus. So to iterate, when he asked this question, I knew where it should be, but I couldn't find it. So then I went digging and looking at other chipsets, and I found that information on an Asus Z690 motherboard. I don't remember the specific model, but under the Thunderbolt header, there was a setting for Thunderbolt configuration that said PCI Express tunneling. And as I was looking through those motherboards, and again looking at my notes, there was a setting that was not on his motherboard that I thought was, but on the next chipset, again, that supported Thunderbolt 4, and the setting was in the motherboard BIOS, PCI Express tunneling over USB 4. Once that feature is enabled, then you've got tunneling, which means puts those 4 lanes out externally. So that's a big deal if you need that. If you don't need it, it's not a big deal. So even though 2 different chipsets on Intel both support Thunderbolt 4, there was a difference in the first chipset to the second chipset for that one feature. That feature, to reiterate, not supported to that feature being supported on the second one. You know, change one thing changes everything. Now, to reiterate, I mentioned the AS Media. I just saw my notes. For the 3242 chipset, it only supports data. So this new AS Media 4242 chipset, I'm curious if it'll support DisplayPort mode. Don't know, should, we'll see. But remember, the chipset was designed with AS Media working in conjunction with AMD. So I want to thank you guys for watching. My name is Gil Boyd. Welcome. I hope we get to make some more videos. I don't know. Things are getting a little bit tough. But I love my subscribers, and I want to thank you guys for joining us on this journey. I hope we can keep going, but we got to get some help. So we look forward to seeing you again, Lord willing.